Thank you so much. Priya, over to you.
Thank you. And thanks for coming to our talk. Welcome, everyone. And a big thank you to Open UK for inviting us on stage. So this talk is for you if you're interested in running open source LLMs on your own infrastructure. And we're seeing that many businesses are getting more and more wary about putting their data on OpenAI or Anthropic or any other proprietary AI platform. And what we're going to do today is show you kind of an alternative solution to working with open source LLMs. And this is an area that's evolving at quite a rapid pace that I think the businesses we talk to do feel like overwhelmed with complexity. And what Luke and I would like to do today is try to peel back that complexity and talk about what it means to run your own LLMs and talk about also our experiences deploying LLMs, but also pitfalls, mistakes that we've made so that you don't have to do them yourself. So, I guess before we dive into the topic, let's take a quick moment to introduce ourselves. My name is Priya Samuel. My role is that of enterprise architect, and I've worked in MLOps for a number of years, automating machine learning workloads, and more recently I work in identity and access management, building that layer for Gen AI applications, and looking at how users' data is authorized on their behalf. Over to you, Luke.
Cool, thanks, Priya. Hi, folks. I'm Luke Marsden, CEO at HelixML, where we're building a private Gen AI stack. I also run a business called MLOps Consulting, where I help clients all over the world do this kind of thing. And we also put together an MLOps community. So if you go to mlops.community, there's tons of good content there on how you run large language models, as well as all of the kind of more classical ML use cases. I previously built a business called Cluster HQ that was around storage for Docker and Kubernetes, so very early in that Docker and Kubernetes world, and then also an end-to-end MLOps platform called .science. Priya, do you want to tell us about LLMs?
Thank you. So I guess if you're sitting in this room and this is new language to you, I doubt it, but then I'm going to give you a very quick overview of what that is, and then also motivate you in terms of the infrastructure side, why use Kubernetes and what that entails. So I'm sure everyone in the room is familiar with ChatGPT, and with the release of ChatGPT from OpenAI, what really happened was that the world of deep learning finally got to the point where machines master language. And this is quite significant because machines mastering language has huge implications in the global economy. It's been transformative for information work in the sense that, almost in the sense that the change that a steam engine or the invention of the internet brought to us. So if you were to step back and look at an LLM, the mathematical explanation of an LLM is that it's a very large multi-dimensional function, and it maps sentences onto other sentences. The input here is a phrase, and this is what is the capital of France. This input gets turned into a vector, which is basically a long string of numbers, and we read the coordinates at that location, and you get an answer that's turned into words. And why run LLMs on Kubernetes? So I guess before we go into that topic, let's pick let's get the infrastructure out of the way. What does it involve? If you're reading values in a high dimensional space, it's much faster on a GPU. And so if you're going to run these yourself, you're going to have to get hold of a GPU. This could be an actual metal machine that you run under your desk and warms up your room like Luke does. Or you could access these on the cloud through AWS or Google Cloud Services or any other provider. So, and you would need to connect that GPU to your Kubernetes cluster. This is typically done with a NVIDIA Kubernetes device plugin, and there you go. That's the infrastructure piece. But why would you want to go through all that trouble? And why even bother? So the main, I guess the compelling reason that we see in the market is around security and compliance. So that is the main driver. If you're a European telco or a health company, you're regulated by very strict regulations on where the data can reside, but also where the compute happens. So the next one is availability and latency. So if you're running an LLM close to where you are, your answers will come back quicker. And you also have complete control over uptime. And we're sort of in this phase where a lot of the proprietary hosted AI platforms, uptime and availability is still quite shaky at the moment. And I guess we live in an interesting time where it looks like open source AI might actually be overtaking the proprietary stuff. And it's going to be interesting how this moves along. And I guess the last reason is costs. So in the long term, the cost of running these models locally are going to be way more efficient than getting an API key onto a hosted provider. We know that DeepSeek is a chain of thought model, which means the longer you leave these models thinking, the better your answers are. So, which incentivizes companies to run these things longer. And that's where the economy starts shifting. And you're better off then with something locally hosted. And finally, why Kubernetes? Why not some other kind of infrastructure option? It's because of Kubernetes being Kubernetes, because of portability, consistency, and scalability. And it's also because most enterprises already have Kubernetes clusters deployed. So use the infrastructure that you've already got to take this along. Right, so that sets the stage for our first demo. And we're going to start really, really simple. So in here, we're going to, by the way, this is going to be a pretty demo-heavy session. So there's a QR code on most of our slides. You can scan that and get that going. It's a link to a GitHub repository with a README with instructions how to get these demos set up locally. All right, on to our first demo. So we're using an open source product called Ollama. It's an open source product for running large language models on your laptop. And if you've got an M1 Mac, you can use your built-in GPU. And really, all it involves is downloading Ollama, installing it, and running it. And you can ask it random questions.
Tell me a joke.
Get back your answer. So this is great. But then in practice, enterprises do not want you to run an LLM on your machine. Top reason, because you wanted to connect your data lake or your GitHub or your Jira or any kind of enterprise data sources that you've got. And the second reason is that these LLMs are really slow on your laptop. They run at 1/3 of the speed as they would on a dedicated GPU. So this is great, but then not quite close. Let's take it one step closer to production. And now we're kind of looking at running Ollama on Kubernetes.
Cool. So let me show you a little bit what we've got going on here from an infrastructure perspective. So this is the GitHub repo that we put together for this talk. It's got full instructions on how to go completely from scratch to set up a Kubernetes cluster, set up the NVIDIA drivers, and then install a product called, or a project called OpenWebUI along with Ollama. So you can do that, and then what you end up with is something a bit like this. I'll make it a bit bigger so everyone can see it, and you can go and chat to your Llama 3.1. That will be talking to a GPU that's running in that Kubernetes cluster, in this case on Lambda Labs. But what I want to do now is motivate one of the problems that you then run into. So you get to this point where you're running this thing on Kubernetes, right? And then you start trying to use it for actual real workloads. One of the workloads that we've come across very often is having the LLM kind of summarize the responses from APIs. So you might have a prompt that looks a little bit like this, present the key information from this API response in a concise manner, and then you've got the API response. And what you'll notice here is that there's quite a lot of API response. It's a fairly chunky response body. So the first problem that you'll run into when you just run Ollama on Kubernetes with something like OpenWebUI in front of it is that Olama has this bug, or rather, it's kind of a design decision, but it's problematic in production, where they restrict the context length down to just 2,000 tokens, or 2K tokens. And what that means, and the thing that they do that's worse than that, is they silently truncate your data without telling you that they've done that. You don't get an error message back saying, like, your request was too long. It just, like, silently chops off some of your data. And so you start building against the system, and then what we found when we were doing that was that we got these weird responses, like, this is an integration against Jira. And the idea was we want to be able to ask the question, show me all the issues in the current sprint, or show me all of the Jira issues. And the response body contains all of the Jira issues, but the actual response just contains one issue, because most of the API response was cut off. And so you get these kind of weird issues. Yeah, that's an example of that initial problem. The way to solve that with Olama in particular is that you have to pass in a specific field called num context, and you have to pass that in through the Olama API. But then if you're using Olama via the OpenAI API that it exposes, then there's no way of passing that parameter through. So if you're trying to use it with this kind of standard OpenAI API, it's kind of broken out of the box, which is annoying. And Priya's actually got some other foot guns, as in ways of shooting yourself in the foot, that we also run into to talk about.
Yeah, cool. What else is broken by default? The thing is, we realize your responses aren't that great. The model will garble its output from time to time. It will come back with some nonsense. And the reason for that is that by default, the Olama models are highly quantized models, which means by default, they use 4 bits of information per weight in the neural network, which means it's a much lower resolution than what you would want to use in production. So it prevents the model from thinking clearly. So what we found was using an 8-bit quantization was a good balance between what is practical and sort of performant enough. And the next thing as well was we had to tweak a few parameters, like flash attention, for instance. This one was by default. The Olama models have flash attention turned off. This means you end up using more memory than you actually need. And turning on flash attention reduces your memory usage. And it also speeds up the transformers, or the LLMs, by processing cross attention into smaller chunks. And this then means you're able to cut the memory from quadratic speeds to subquadratic with context length. So this gets you to a point where you're running Llama 3.3 on a Kubernetes cluster. You've done some tweaks, it works. But then Olama is really built for running stuff on your MacBook. And models are highly quantized. It's designed to run with Slack and Chrome and all the other stuff. So we then move that along closer, much closer to production, with another popular project called VLLM. And VLLM gives you high performance inference. And they've just launched a newer version of VLLM, which is 1.7 times faster for inference. And on the right, you've got your Kubernetes spec. There's a few things that, I don't know if you can see it, but a few things I'd like to point out on that. First time, this is just a deployment spec. It pulls in VLLM, and it starts off VLLM with some parameters that instruct it to pull Mistral 7B and get that running. We also, I guess you'll also note that we're passing in a Hugging Face token in order to download the model.
So shall I show a quick demo of that?
Go on.
Yeah. I'm going to very quickly show you that we've also, in these instructions, shown you how to set up VLLM. There's some Kubernetes manifests in this repo. It's slightly less kind of easy to use than Olama and OpenWebUI. You actually have to do a little bit more work. But what you end up with, if I show you, so hopefully this is still working. Actually, I need to get rid of that one. So if I do kubectl get pods, I can actually show you the cluster that we've got here. And what you can see, there's a whole bunch of stuff running in the cluster. But the particular thing here is that we've got this VLLM pod that Priya showed the deployment spec for. And we've also deployed a tool called Helix that we're working on just as a front end to that VLLM. So what you can see if we do the right port forward, sorry, I was jumping between two different port forwards here to talk to Web UI. There we go. So it really didn't like switching from one port forward to another. Oh, what are you doing? Okay. Sorry, live demo. I should have prayed to the demo gods.
Yay. See something.
Is that kind of better? There we go. Yeah. Okay. I mean, port forwards on localhost, there must be some cookie problem or something. This is it's all fun and games with Kubernetes. So what we've got is we've got the Helix front end running on top of VLLM here, which is the project that we've been working on. And what you can see is it's inherited that model that we configured in VLLM and showed that in the list of models. So you can say, hey, and the nice thing about this is it comes back really fast. So like Priya was saying, VLLM have really optimized inference, and it's 1.7 times faster in the latest build. And then you can also do fun things like you can set up RAG in this environment. So let's see my apps here. I've got a talking brochure. I've uploaded a PDF, and it's chunked that up, put it into a vector store, and then you can say something like, tell me about helix.ml. And what you'll see here is that VLLM is doing a really nice job of very rapidly taking that context that's been injected into the context window and then coming up with a nice description of what was in the PDF, which was a PowerPoint presentation. Yeah, VLLM is cool. We're finding a lot of customers deploying VLLM as kind of a baseline of infrastructure in their business, and so VLLM on Kubernetes is looking like the dominant way that people will run open source models on Kubernetes. Yeah, so back over to you, I think.
Cool. Remember the spec we showed you earlier? It had an environment variable that said, here's where you inject your Hugging Face token. And one of the reasons for that is that VLLM downloads the models from the weights for the models from huggingface.com, and this getting the token is a gated process. You have to go in and agree to terms and conditions, and then get your weights for the model. So this means you can't really use this in an air-gapped or an offline environment where it's genuinely private. And so we got thinking, how do we avoid that? And we then had an option: do we bring in an in-house model registry, or is there something other solution? And we kind of said, no, we don't need a model registry. Let's just use a Docker registry, because that's something that we have already. So we baked the weights into the model and into the image and checked it into Docker. But then we did run into an issue with that, because Docker compresses images at a pretty high level, which is defaults to a gzip level 8. And it just means it takes a long time to decompress the model. So we then thought, okay, the simplest, there are fixes for this in Docker in their newer experimental versions, but we patched Docker source code on the machine that's building these images to get to have just a bit more flexibility in terms of levels of compression. And everything else runs exactly the same, and that got us through our Docker registry working as our model registry. Let's step back a little bit into the bigger picture problems. Notice in the Kubernetes spec, I had to specify exactly which LLM I want to serve. In that case, it was a Mistral 7B model. And in reality, you'd want to serve multiple models, because they're all good at different things. Some models are good at code generation, others at multilingual questions. And And that's one issue. The other issue is that Mistral 7B uses about 7 gigs of your GPU memory. The rest of your GPU is just sitting idle. There's not much to do there, and you're paying for it. So if you do want to run multiple models on your cluster, you then either look at having multiple Kubernetes deployments or look at investing into GPU scheduling. And Luke's going to give you a demo about the GPU scheduler that we wrote. And this helps to not just have multiple models serving at the same time and using the GPU, but also we can mix then fine-tuning jobs and inference jobs.
Yeah, so like any good cloud-native engineer, when faced with this problem, we decided to build our own scheduler. Let me see. So I just wanted to share a little bit of that. The way this works is that you can see, if I go to the right URL, then we've got here, let me just log in quickly. It's because I'm in an incognito window, because I was messing around earlier. Sorry about that. OK, so what we can see is that what we wanted to do for this deployment was to offer a wide range of different models. So you can probably see here, these are all the different models that we wanted to offer here. So we've got Llama 3.1, 8B, which is fast. The 70B is slower, but gives you better answers. And then, of course, we couldn't help ourselves, and we had to add DeepSeek just a couple of days ago. And the idea here, and then there's Aya and the Phi model from Microsoft. They're all good at different things. The Aya models are particularly good at being multilingual, like Priya said. The DeepSeek models are good at chain of thought. So depending on the use case, you do want to use different models. And so what we have, you can see here that we've plugged this system into about 20 GPUs that we're running in production on this system here. And what you can see is that the scheduler that we wrote is deploying different model instances onto different GPUs. And it's kind of dynamically choosing what to place where based on the load on the system. So for example, if I say, hey, here, and if I need to ask it to do something longer, tell me a story, and then if I'm quick, I can catch it. So that's running on this machine. It's an L40S. And then I can go in here and I can also run some DeepSeek and say, what is the meaning of life?
Oh, that's an easy one.
Well, it's going to have a long think about it. Yeah, I know I was inspired by the Douglas Adams being piped through the restrooms. But no, it's not 42. OK, anyway, that's interesting. But then you can also see what happens if I try and spin up a model. I don't think I've got any Quen running on here at the moment. So if I try and use the Quen model, then what that's going to do is it's going to have to pick a node that's got enough free GPU memory and then allocate a Quen instance to that node. It makes the user wait for a minute while that gets loaded into GPU memory, but it's pretty quick. And then next time you ask a question, I'll just say hello again, then that model is loaded into GPU memory already. And so the scheduler will also then automatically unload models that are not used and kind of optimize the trade-off between GPU memory usage and user-facing latency. Mm-hmm. So I then want to talk just very briefly. I know we're about to run out of time. 8 seconds. OK. We've got some layers on top. So why do you deploy an LLM? It's not just so that you can ask it how many R's are in strawberry. You want to integrate it with your business data and your applications. You want to do RAG, and you want to be able to ensure quality by doing evals and doing CI/CD using LLM as a judge. And all I'll say is, if you're interested in that topic, kind of the layers on top, please come along to our workshop, which is building reliable GenAI apps at 4:15 in the Elizabeth Boardroom. And thank you, Priya. Thank you, everyone. Thank you so much.
Thank you.